Yeah, so this is going to be a quick introduction why I use the EtherCat, Ethernet for Control Automation Technology. That's also an international standard, but it's also Beckhoff, which is a German supplier for automation or soft PLCs and automation. So if we have a little look at it here, talked about EtherCat for control automation. This is just for information. There's also a technology group where most of this information is collected from. And here, of course, it's the technology group about them. And again, this is Balthasar's Miracle Medicine. They are, and this is the best you can get. But there are drawbacks, there are pluses and minuses with this one too. EtherCat connectors, you have some types here and the pin layout for RJ45 and M12, M8 and so on. Cable color as a standard for this too. The length, maximum length, and what kind of category of cable quality you need to use, and so on. So what it does basically here, the way it works is that we have a frame, we have masters and slaves. And the master, he just transmits a data frame to the slave. The master can have its own data here, and then they add data. The slaves add data in registers here in frames down here and return it to the master. So this is awfully fast. And here, for the master, you can use a standard Ethernet controller, but the slaves, they need a special Ethernet controller because this coding and encoding is done in silicones. It's awfully fast. Real-time capabilities. Real-time capabilities, the determinist that, okay, we know the time is going to take through here, and I get this telegram back at the same time, all the time. So that's the way it is. And the hardware you can use, can even run it as on a Raspberry Pi if you want to. That's not high quality software, but then the slave needs this special component here too for let's say encoding and decoding. Slave controller. And microchip has one like this, for instance. Yeah, ESC. But as a master, you can use a Raspberry Pi, but you should probably opt for some better quality hardware. The telegram structure here too, that we looked at a little here, is these are for the slaves here too. So any number, and this error check in the end, the frame control check. This is a CRC of some called CSO32. Yeah, and they're padding too here too if they are so they have the same length all the time. This is for the silicon decoding to do. Telegram structures, and here is how it works. We have looked at this for quite a few times now. Then you have logical address. Of course, these are use IP addresses and so on, but there are logical addresses within here too. So where should I place my telegram here? What slot do I have in here? Yeah. Short cycle time refresh data on the drives, but using longer cycle time to normal I/O, because drives we are running the motors, so it has to be fast. And direct memory access, you can read this for yourself. Network topology too, you have power also that you can supply here too. On the bus, it can administration of data and power with a single cable. 65,000 devices on the EtherCat segment, which is theoretical. You should probably not use that many devices, but it's theoretical. And here's a little how it is. And there is a master, and here are the network and so on, switches and so on. Here is our power switch then to use, and you can use fiber optic too. Cable redundancy you have got here. So a break in a cable, they communicate two ways of communicating to the devices. Also, let's say you can handle one error in the network, but two you can't handle, then you are going to lose devices. And now too, if you're looking, especially at back of this master can be redundant too. So you have redundant controllers here in this system. But here is the network redundancy for I/O and so on. And here was this PoE, power over Ethernet. That's that you have one cable. Of course, you have power in the cable, and you have transmit and receive. Where you can supply the slaves with power, so you only need one cable to the device. There's communication and power in one cable. Of course, often there's not a lot of power being supplied here, but it's sufficient to run the slave itself in some cases. And then we go into here for EtherCat is gigabit. That is on the way. That's the speed. So you have gigabit backbone, and you have drops down to 100 megabit services, and then these just occupied slots in the gigabit Ethernet. So the master can communicate really fast with a lot of devices here to keep the speed up. And EtherCat is fast. It's awfully fast. I think I read somewhere they had 400 analog values with quality code and timestamps. They communicated a lot in 250 microseconds, and it's probably faster now. Okay, that was it. So again, information on EtherCat, and this here you can read for yourself. So I just highlighted some of this. So it's just for information, but you can pause this video and just read what's in here. And of course, go to the homepage for the EtherCat organization, where all this information is basically collected from. There you will get more information. So this is just a brief introduction.